We're going to start with honors functions. All right, so the first question of it is question 5, which is a linear expression with h of 3 plus h of 0 equals 5 and h of 3 minus h of 0 equals 9. And because of the h of 0s being inverses of each other, we can eliminate those two and then add the rest of them. So that becomes 2h of 3 is equal to 14. So dividing 2 from each side gives us h of 3 equals 7, which is our first point when the equation of h is x is equal to 3, y is equal to 7, so our first point is 3 of 7. And then we can plug that back into our original equation, h of 3 plus h of 0 equals 5. And then that gives us 7 plus h of 0 equals 5. So subtract 7 from both sides, gives us h of 0 equals negative 2, which means when the equation x is equal to 0, the y value is equal to negative 2, which gives us our second point, 0 equals negative 2. With these 2 points, we can put them into the slope formula, which gives us negative 2 minus 7 over negative 3 minus 0, which is negative 9 over negative 3, which is 3. All right, now that we have the slope and the y-intercept from the point 0, negative 2, we have the equation h of x is equal to 3x minus 2. And now that we have this, we can plug our wanting to know h of value, which is h of 6, into there, meaning h of 6 is equal to 3 insert times 6 minus 2, which is 18 minus 2 equals 16. So h of 6 equals 16. Our next problem in honors functions is question 6, which is f of x is equal to 2x squared plus 1. Express f of 2y squared plus 1. So the first thing you do obviously here is substitute, and you put the f of 2y squared plus 1 into x, and that gives you 2 in parentheses 2y squared plus 1 to the second power out of parentheses plus 1. And then to bring the insides of the brackets into the second power, that gives us 4y to the fourth power plus 4y to the second power plus 1. And then we can distribute the 2 on the outside from the beginning, which gives us 8y to the fourth power plus 8y to the second power plus 2 plus 1 for our final equation. Then you sum that up to 8y to the fourth power plus 8y to the second power plus 3. And that's the answer for question 6. Now we can move on to our second card, honors quadratics. For our first question, we're doing question number 2. So we are going to find 2 intersecting points of the lines g of x equals 11x and f of x equals 2x squared plus 12. This starts with us being able to put them equal to each other because their points are intersecting, meaning these 2 lines at this point have to be equal to each other. So that puts us at 11x equal to 2x squared plus 12. And then you can set that equal to 0 by subtracting 11x from each side. This gives us a quadratic. So we just put that into the quadratic formula, solve through, which gives us 11 plus minus square root of 25 over 4, which is 11 plus minus 5 over 4. Solving this, we get the 2 roots 4 and negative 3 over 2. Putting these 2 roots back into the equation, g of x equals 11x gives us 2 points. So 1 point is negative 3 over 2, x and negative 16.5y, and the other point is 4x 44y. With these 2 points, we can put this into the distance formula, which is x2 minus x1 squared plus y2 minus y1 squared square rooted. Solving through gives us the square root of 762.5, which is approximately 72.61. All right, so now we're going to do question number 3. For question number 3, we're going to find the sums of the square roots of 2 different equations, and then we're going to add them, and then add them into a fraction, then add them again to find the final answer. So the first of the 2 equations we need to solve is 15x squared plus x equals 6, and subtracting 6 from both sides gives us 15x squared plus x minus 6 equals 0. That lets us put that into the quadratic formula, which we can solve through to find -1 plus minus the square root of 361 over 30 equals 0. The square root of 361 is 19, so it becomes -1 plus minus 19 over 30 equals 0. Then we can move on to the second equation, 12x squared plus 19x minus 18 equals 0. Put that straight into the quadratic formula, which gives us -19 plus minus the square root of 1,225 over 24. And then we can square root that into becoming -19 plus or minus 35 over 24 equals 0. All right, so now we just solve through those. The first one, -1 plus minus 19 over 30. The plus minus, so -1 plus 19 over 30 becomes 3 over 5, and minus 19 becomes -2 over 3. And then to set those two, to find the sum of that, we set the 2 denominators equal to each other, which is 15. So that times 3 over 5 by 3. So the denominator becomes 9 over 15, and -2 over 3 by 5. So the numerator, becomes -10 over 15. And then subtracting those 2 from each other because of the negative becomes -1 over 15. That's the answer for our first one. And then for our second equation, it is -19 plus minus 35 over 24. So plus 35 is 16 over 24, which simplifies down to 2 over 3. And for -35, it's -54 over 24, which becomes -9 over 4, which, setting the denominators equal to each other again, becomes 8 over 12 minus 27 over 12, which becomes -19 over 12. Now to find the fraction that we will add to become the final answer, we have to take the 2 sums of each equation and add them. So that means, once again, make the numerators equal to each other. So it becomes -1 over 15 plus -19 over 12. Those 2's denominators come down to 60, and then adding the 2 together becomes -99. That simplifies down to -33 over 20. And then our fraction that we want is a over b. So -33 over 20 means a is -33, and 20 is b. -33 is a, and 20 is b, which, adding our final solution is a plus b. So -33 plus 20 equals -13, which is our final solution. Our next and final card is Honors Quadratics Part 2. Our first question is going to be question number 2. So we're finding all real values of 2 equations. The first one being 2x squared plus yx plus 3 equals 0. And our second one being 2y equals y squared minus 35. All right, so to start this one off, we have to set our second equation equal to 0 to solve the roots of y. That we do that by just subtracting 2y from both sides. Then we get y squared minus 2y minus 35 equals 0. And the two roots from this parabola are 7 and -5. We then go to plug both of those roots back into the first equation for y to solve for x. The first one we're going to do is solution number 1, 7. So that becomes 2x squared plus 7y plus 3 equals 0. And that gives us the parabola. So we use quadratic formula to solve through to get -7 plus minus the square root of 25 over 4. Obviously, the square root of 25 is 5, so it becomes -7 plus minus 5 over 4, which solves out to be -12 over 4, or -3, and -2 over 4, which solves out to be -1/2. Then we go to solution number 2, which is -5, and put that into quadratic formula. It comes out to be 5 plus minus the square root of 1 over 4, which is just 1. So 5 plus 1 over 4 is 6 over 4, or 3 over 2. And 5 minus 1 over 4 is 4 over 4, which is just positive 1. Our next question is question number 6. That is all possible solutions of the equation x squared minus 3 to the second power times 3 plus x squared minus 3 times 5 rather, and minus 2 equals 0. To start this off, we need to solve all exponents. So x squared minus 3 becomes multiplied by itself. So that gives us x to the fourth power minus 6x squared plus 9, and then all that in parentheses times 3. And then on the other side of the equation, we can still distribute 5 into that set of x squared minus 3, giving us 5x squared minus 15, and then minus 2 equals 0. All right, then we have to distribute 3 into x to the fourth power minus 6x squared plus 9, which gives us 3x to the fourth power minus 18x squared plus 27. Then we combine like terms to become 3x to the fourth power minus 13x squared plus 10 equals 0. From here, because this is just a parabola squared, because all the exponents are doubled, we can put this into the quadratic formula with the answer x being squared, because that'd be the same as the square rooting all of the original equation and then putting that to find normal x. And this works much easier. That gives us 13 plus minus the square root of 49 over 6, which the square root of 49 is 7. So 13 plus minus 7 over 6. So to find our first root, we're going to do 13 minus 7 over 6 gives us x squared. And solving through that, 6 over 6 is our answer, and that's equal to 1. So x squared equals 1, and then we can square root both sides to solve for x, giving us x equals plus or minus 1. We can do the same thing for adding, which is 13 plus 7 over 6, which is 20 over 6, which is 10 over 3. So 10 over 3 equals x squared, so we can square root both sides to become the square root of 10 over the square root of 3. And because we can't have a square root as a denominator, we have to multiply both sides of the fraction by the square root of 3, which gives us square roots cancel out, giving us 3 over the square root of 30. Plus minus the square root. So plus minus the square root of 30 over 3 equals x.